Back. So this is problem 1, section 3-7, optimization problems on webwork for me. If 900 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of the box. So yeah, understand. So I have, say, material. Suppose I have some paper, 900 square centimeters. I'm going to make a box with a square base and open top. So a box looks like this, right? So this is the open top. Underneath it is a square base, you see? So underneath it, I'll make it, say, like this. Got that? So there is a base and an open top. Then you have the sides. So because the base is a square, the length is x, width is x, height is h. Okay? So you want to make a box with 900 square centimeters of material with the largest possible volume. Now, what is the volume of a box? Right? It's length times width times height. So x times h. All right? You want to maximize this function. But notice this function has two variables, x and h. So somehow you want to get rid of maybe h. All right? That's the point. When you're maximizing, you are going to take derivatives, and we don't know how to take derivatives as of now when we have two variables or more variables. So we need to reduce our problem, our expression, to a function of one variable alone. That's where the 900 square centimeters of material comes into play. All right, so let's look at 900 square centimeters. Let me cut off the box on the sides. When I cut off the box on the sides, they lay out flat. That's my base. And these are the four sides which came off, right? There was no top. There was no open. The top was open, so there is no top. So this is this. This is the entire material. So this is called surface area. All right. What is surface area? Area of this entire mess that's left behind. The base is a square, so x times x, x squared. And each side is a rectangle. Length x, width h. So the height became the width when you lay it flat. For each side, length x, width h. Length x, width h. Length x, width h. So 4 times x times h. That's for each rectangle over here. X squared comes from the square. XH comes from each of the rectangles. So 4 of these. That is your surface area. What do we know? Surface area is 900 because that's how much material we have, 900 square centimeters. So volume is x squared h and surface area is 900 square centimeters. So now let's start playing with this. X squared plus 4xh is 900. So I will move the x squared to the other side. I have 4xh equals 900 minus x squared. H is 900 minus x squared all over 4x. Okay? Why did I do this? Remember, I want to maximize volume. Volume has two variables, x and h. I don't want h. So somehow using surface area, I was able to solve for h. I plug in this value that I got for h into the volume expression. So x squared times 900 minus x squared over 4x. Okay, let's see whether we can simplify this. There is an x in the bottom and that is an x squared. So one of the x's cancels one of the x's. I'm left with x for the top or the multiplier, and there is no x in the bottom. Now, this division distributes. So why don't I distribute? So that gets me 225. That gets me x squared over 4. And this x is the x from outside. Now distribute the multiplication. X times 225x minus x times this quantity. So that is x cubed over 4. What is this? This says my x, the worst it can get is 0. The best it can get is 300. Is that so? Why? Let's see. X is the length of the base. It cannot be negative. So it has to be at least 0. All right. Why should it be at most 300? Well, because I have surface area of 900. So if I make 300, it shouldn't be 300. It should be 30, mind you. That's a mistake. Where did it go? There you go. It should be 30 at most. Okay. So why should it be 30? Because 30 times 30 is 900 already. Okay. So the highest x can go is 30 because that's square root of surface area. You understand? So if I spend all of my material in the base square, I have no height. All right. Regardless. So that's the range for my x. Worst it can get is 0. The best it can get is 30. Okay. Now, let me use v, which I need to maximize over this particular range. All right. Over this particular domain, rather. So, how do we know to find maximum of any function? Well, we need critical numbers for v. So, take the derivative of v. 225x gives me 225. This gives me 3x squared over 4. I set the derivative to 0 because v prime undefined cannot happen. You understand? So look, this is a polynomial. So there is no place where it is going to be undefined. So v prime is always defined. So the only way you get a critical number is by setting v prime to 0. That is 225 minus 3/4 x squared is 0. Solve for x squared. So let me move this to the other side. So that negative becomes a positive. 3x squared over 4 is 225. 225 is nothing but 225 over 1. Why would I do this? Cross multiply. 3x squared equals 900. So divide both sides by 3. X squared is 300. So taking square root, x equals plus or minus square root 300. X cannot be negative, right? So it is only the positive value we choose. Square root 300. Now x is between 0 and 30. Remember, 30 was the max you could go. So we want to find value of v at 3 different numbers. The endpoints and the critical number. And see which one gives you the maximum. Okay. V at 0, plugging it into the function value v. Remember, v is this function. So that's what I'm substituting at. When I plug in 0 here, 0 here, I get all 0. V of 0 is, so this is v of x. I'm sorry. This is v of x. V at 0, plugging in 0, I get 0. Now the other endpoint is 30. Okay. Now I don't know what this is. So let me calculate. Well, fortunately, we have Google, right? So 225 times 30. Okay. So what was I? I want to evaluate at 30. So 225 times 30 minus 30 power cubed over 4. All right. So what is the value? The value is 0. Okay. So this is also going to fetch me 0. So this is how you would do. You would find its value. Okay. Either using a calculator or wherever. Yeah. Online calculator. Now, what was the other option? The critical number, square root 300. Now, they are asking us to maximize the volume. Well, the point is, both these endpoints gave me 0. So this should, I hope, give me positive value. Let's see. So instead of 30, I have square root 300 now. All right. Square root 300. All right. Square root 300 to the power 3 all over 4. That gives me 2598.0. Oh, whatever it be, it is a positive number. So that gives me the maximum. Okay. Endpoints and value at the critical number. So this was square root 300. All right. So how do I plug it in? Try in WebWork, do not give an approximation because it could possibly give you tell you are incorrect simply because your approximation and its approximations are different. So I will write this. How do you write this in WebWork, right? That's an important tip. Now, okay, this is something many students ask me, so let me explain. We are trying to write volume and they also want us to include units, okay? So centimeter cubed also has to be written. So let's see. 225 times square root SQRT 300. All right, that's the first part. Minus, whenever I see a quotient, a fraction, I write parenthesis over parenthesis. Denominator is easy, so I'll write a 4. Okay. Numerator is a power of square root. So square root goes inside, mind you. Okay. So I'll put the square root there. Square root of 300. And power is written with a hat 4. Oh, sorry. It was a 3. Power 3. And then don't forget centimeter cubed because they are asking us. Okay. Centimeter cubed. Okay. Which is correct. All right. Preview is a good place for you to check whether this is exactly what you wanted it to be. Because this is where you know how you have entered your answer. All right. So we are done here. Until next problem.